So first we need the matrix of the coefficients. In this case, that is 1, 1, 1, 1, 2, 3, 1, 3, 4. The next matrix is the matrix of the variables x, y, and z there. Then the final one is the one for the results 1, 4, 6. So this is A, this is X, and that is B. So for us to get X, you're going to need the inverse of A, then you multiply by B. Okay, so let us get the inverse of A. So for us to get the inverse of A, you're going to need 1 over the determinant of A, then you multiply that by the adjoint of A. So for the determinant of A, you're going to have 1. So when you cover the row and the column for 1, you're left with 2, 3, 3, 4. 2, 3, 3, 4. Minus 1 there. So if you cover the row and the column of that one, you're left with 1, 3, 1, 4. 1, 3, 1, 4. Plus this one here. If you cover its row and column, you're left with 1, 2, 1, 3. That is 1 into 2 times 4 minus 3 times 3 minus 1 into 1 times 4 minus 3 times 1 plus 1 into 1 times 3 minus 2 times 1. So that is 1 into 8 minus 9 minus 4 minus 3 plus 3 minus 2. So that is negative 1 minus 1 plus 1. So the determinant is negative 1. And then let us look for the adjoint. So for the adjoint of A, we are going to look for the cofactors of all the entries in that particular matrix. So let us start with the cofactor of 1, the first one there. So that will be negative 1 raised to power. So it is in row 1, column 1, that is power 2. Then when you cover its row and column, you're left with 2, 3, and 3, 4, and 3, 4. So that is the same as 2 times 4, that is 8, minus 3 times 3, which is 9. So that is negative 1. Then we look for the cofactor of the next one, which is 1 there. So negative 1 raised to power. So it is in row 1, column 2, that is a power of 3. Then when you cover its row and its column, you are left with 1, 3, 1, 4. 1, 3, 1, 4. So because the power is odd, we are going to have a negative there which holds. So we have a negative into 1 times 4, that is 4, minus 3 times 1, that is 3. So inside there we have 1 times negative 1, that is negative 1 there. Then we go to the next entry there, which is 1. So we have 1 raised to negative 1 raised to power. So 1 is in row 1, column 3, that is a power of 4. When you cover that row and that column, you have 1, 2, 1, 3, 1, 2, 1, 3. So you're going to have 1 times 3, which is 3, minus 2 times 1, which is 2. So that is 1. Then you go to the next one, which is 1. Negative 1 raised to power, it is in row 2, column 1. So that is a power of 3. So when you cover its row and its column, you're left with 1, 1, 3, 4. 1, 1, 3, 4. So you're going to have a negative there into 1 times 4, which is 4, minus 1 times 3, which is 3. so that will be negative 1. Then you go to the next one, which is 2. So negative 1 raised to the power. So 2 is in row 2, column 2. That is the power of 4. So when you cover that row and that column, you're left with 1, 1, 1, 4. 1, 1, 1, 4. So you're going to have 1 times 4, which is 4, minus 1 times 1, which is 1. So that is 3. And the next one there is 3. So negative 1. So 3 is in row 2, column 3. That is the power of 5. When you cover its row and its column, you're left with 1, 1, 1, 3. 1, 1, 1, 3. So you have negative into 1 times 3 is 3, minus 1 times 1, which is 1. So that is negative 2. And the next one is 1. Negative 1 raised to power. So 1 is in row 3, column 1. So that is a power of 4. So when you cover its row and its column, you have 1, 1, 2, 3. 1, 1, 2, 3. So that is the same as 1 times 3, which is 3, minus 1 times 2, which is 2. So that is 1. And the next one we have 3. So 3 is in row 3, column 2. That is a power of 5. So when you cover its row and its column, you're left with 1, 1, 1, 3. 1, 1, 1, 3. So you have negative into 1 times 3 is 3. 1 times 1 is 1. So you are left with negative 2 there. Then finally we are at 4 there. So 4 is in row 3, column 3. So that is a power of 6. When you cover its row and its column, you're left with 1, 1, 1, 2. 1, 1, 1, 2. So you're going to have 1 times 2, which is 2, minus 1 times 1, which is 1. So you have 1. So the adjoint of A therefore is negative 1, negative 1, 1, negative 1, negative 1, 1, negative 1, 3, negative 2, negative 1, 3, negative 2, then 1, negative 2, 1, 1, negative 2, 1. That is the adjoint. So for us to get the inverse of A, just take 1 over the determinant. The determinant was negative 1. Then it multiplies the adjoint, which is negative 1, negative 1, 1, negative 1, 3, negative 2, 1, negative 2, 1. And that's going to be equal to 1, 1, negative 1, 1, negative 3, 2, negative 1, 2, negative 1. So for us to get x, which is x, y, z, we're going to pre-multiply the matrix B by this inverse that we have. So we have 1, 1, negative 1, 1, negative 3, 2, negative 1, 2, negative 1, times 1, 4, 6. So we're going to multiply 1 times 1 plus 1 times 4 plus negative 1 times 6. Then here we're going to have 1 times 1 plus negative 3 times 4 plus 2 times 6. Then we're going to have negative 1 times 1 plus 2 times 4 plus this one is negative 1 times 6. So if you simplify that, we're going to have 1 plus 4 minus 6. You're going to have 1 minus 12 plus 12. You're going to have negative 1